To answer the question of is ChatGPT sentient, you have to ask yourself a different question to my mind, which is what does ChatGPT want? And I don't know if ChatGPT wants anything. I do hope that when it comes up that it does want something, it's going to be like benevolent AI and not Skynet, say, or Ultron. I don't know. We'll find out.
Our brain is the most incredible artifact we know of, and consciousness is one of the greatest mysteries. The average human brain weighs about 3 pounds, similar to the average laptop, and consumes only 10 watts for its higher functions, the same as an LED light bulb. Yet it can still perform better on our state-of-the-art benchmarks or write a better novel than a 10 megawatt GPU cluster. That's a 1 million x less energy. As Emily Dickinson wrote in 1862, the brain is wider than the sky, for put them side by side, the one the other will contain with ease, and you beside. I'm here today with my friend Dr. Elad Liebman to discuss consciousness, AI, and the latest advancements in the road towards AGI. We'll touch on ChatGPT o3's new all-time 87.5% ARC test record, and questions like what makes us human. To start off with, Elad, tell us what brought you to the world of AI research and what is your background in the field?
It's oftentimes it's presented as though, there's machine learning and then there's artificial intelligence, and somehow machine learning sort of took over what used to be artificial intelligence. I came from the machine learning world. I've spent my entire professional career in data and modeling of complex systems. And then when I started my undergraduate studies, I started collaborating. I was interested in content recommendation, primarily music. I also have a background in music. Some people may know. Most people won't know. Most people don't know who I am, which is fine. I wouldn't know who I were if I didn't know myself. And like as Shalom Chanoch, the Israeli famous musician, says, a person to himself is a stranger. So who knows? Um, I was taking a class with a professor, and we were talking about music, and we were doing a computational biology together. And I was commenting that it's interesting to think about how musical genres evolve as almost like a natural organic process. And he was like, "That's a great idea. Why won't you write a thesis with me about that? Why won't you be my student and work on a thesis that does that?" And then I ended up basically continuing my undergraduate degrees. So I did a double major undergrad in computer science and music composition, and then I continued to a master's, basically using techniques from artificial intelligence and I would say computational biology to analyze how musical genres evolve. And after that, I felt I wasn't satisfied and I wanted to explore more. So I went to the US to get my PhD in machine learning and computer science, and I worked on basically content recommendation. I was actually my dissertation research is in the intersection of content recommendation with music as like the main driver, but not the only one, and sequential decision making. And the idea is like and this is a part of it actually led to my work in the cognitive sciences. I actually have a couple of studies that are more in cognitive science journals. It's more of a question of how do people perceive, how do people experience contents differently in different contexts, with different contextual cues, and how can we leverage that to plan a person-agent interaction in a way that is more conducive to enjoyment and collaboration. So in between of all of that, I also worked in robotics for a long time. I worked on also part of kind of circling around overlapping ideas of like emergent cooperation and how to ascertain others' intentions. Like, can you judge, like if you're a robot and you're playing soccer with a human, can you understand from the human's body language what their intentions are? And things like that. Can you design complex plays based on those types of things? So those are the types of questions that interested me. That also led me to interest in modeling physical systems. And I think the biggest time that this idea of understanding complex systems, which I think connects a lot of our technological concerns, be it the internet or robotics or artificial intelligence or human cognition. It's about understanding the interplay of complex systems, which, relates to kind of the Norbert Wiener idea of cybernetics. In the 50s, again, I feel like I'm going on a tangent, but like artificial intelligence was kind of decided on as a term by committee in the mid-50s to kind of separate itself from cybernetics. But for a time, those were like competing terms for like similar ideas. It's kind of like, to borrow terms from your own world, it's kind of like people saying, Bitcoin, not crypto, or like, or like, no, this is not crypto, this is the blockchain. So like, there was this whole kind of argument about deciding the perimeter of different overlapping ideas. And that was also the precursor for what would be called artificial intelligence. For the longest time, artificial intelligence was not driven by what ChatGPT does or how these models work. It wasn't driven by data. It was by design, based on search algorithms, based on graph algorithms. And then in parallel, the field that I come from, actually, which is statistical learning and kind of learning theory, emerges. And it's not considered AI. It's considered like its own thing. They end up being kind of slowly merging together in the 90s and the 2000s up until the present day. But you could also almost argue that machine learning has taken over AI, and now AI is taking over the world. That was a long introduction, but yeah.
Super cool. And I'm looking forward into diving into that a little bit more in the talk. So can you tell us a little bit more about the latest news on ChatGPT 03? On December 20, OpenAI announced that it has scored and breakthrough 70.7 ARC AGI semi-private evaluation, and the higher compute configuration that is not eligible for the prize scored 87.5. Can you tell us more about this test, what it means, and what makes ChatGPT 03 different from its predecessors?
I don't want to speak about those tests specifically. I will say that there's a lot of active contention. Like if you listen to someone like Francois Chollet, he's a well-known figure in the machine learning community. He's one of the people who built a canonical predecessor tool for like one of the more common tools for machine learning these days. He has given basically a very interesting lecture in October for the AGI conference, where basically arguing that, again, I don't want to oversimplify his argument, but the idea was that he thinks it's about, real intelligence is about abstraction and generalization. And I think in the very least, it's hard to say how much these models, the new models that we're seeing, because of their size and because of the amount of training data that they use, how much they generalize and how much are just really, really good, sophisticated lookup machines. Like how much are they able to pull from basically unbounded amounts of training data in history to align because what are these? It's important to kind of understand that these machines are ultimately these giant embedding systems. They take in a lot of data and they learn how to represent it in a very compressed but highly complex way as a text completion engine. It's the idea that they're trained to basically be able to predict from text other relevant text. That's basically how they're designed. One of the innovations of the 1 through 03 models is that they add this, as part of their mechanism, they're not just these one-off inference steps, like give me a prompt, I'll give you an out. They do they mimic this sort of chain of reasoning type structure of inference. And I will separate two things. First of all, I think that the ideas there are super cool, and I think there's something of value that needs to be understood. I'm not convinced that we fully understand what these models what passes for reasoning for these models. Because, I mean, we could sort of see this, there's this hubris you were talking about, kind of, there's a bunch of, we might be talking about this, I guess, later, so I don't want to foreshadow too much. But there's this question of how much reasoning, how much of what we call intelligence can be just emergent from scale. Like if you take a randomly initialized giant neural architecture and just throw data at it and use gradient descent, use the techniques that we use to train these models, and you just do it for a very long time on a lot of data, well, with enough time and enough data, a brain emerge, like a brain equivalent emerge. I would argue that in the very least, we know for a fact that these models, you started off with this, that the brain does a lot with very little. I have children. I've watched my children learn, and I know for a fact that they can learn really fairly complicated things through dialogue and interaction, and they don't need to consume the trillions of texts that have been written in the English language over and over again over the period of 10 months to learn that. So, in the very least, we can argue that the human brain learns differently from compared to, say, ChatGPT. That is not to say, by the way, that that means that we're not on a path to some form of intelligence, right? I think it's important to make that distinction, that not being able to recreate how the brain evolved doesn't mean that we're not on path to building a brain of our own, a different form of. And again, I'm using a brain as kind of like stand-in for like intelligence, partly because it's very hard to define what intelligence is. We have a lot of functional arguments for what we expect, how we expect intelligence to manifest itself, but we don't. I would argue that this is not a solved philosophical question of what is intelligence. You can see animals behaving very intelligently, and it's not entirely clear how much self-reflection abilities they possess, or how much they can even explain. I will say this: a human baby is born, and it knows nothing of the world, but it comes pre-baked with 1 billion years of evolution on its side. In a way that our models, no matter how much wisdom we imbue into them via the way they're designed, we cannot rival that. And I think part of it is I think part of humility is to understand that the brain's complexity is so enormous that it's, I think, premature to assume that we know how to build something analogous just through persistence. Anyways, I think about those benchmarks, I'm not convinced. It's like one of those things when they tell you that ChatGPT passed the bar exam, or that it passed got a perfect score on the LSATs or whatever. Like one of those things. I'm not, because we don't fully understand how the training data relates to the task at hand. We don't know how much. Like recently, there's been a published study, I think around August, where they compared doctors or medical interns to LLMs answering medical questions. If it's an open book, if it was a closed book, like the doctors without access to medical information did much worse than ChatGPT, etc., which is understandable. Then it was an open book, like with the doctors having access to the internet, to textbooks, etc., they outperform ChatGPT quite substantially. Then there's a different study that shows that if you give it like textbook, if you give doctors and ChatGPT textbook questions, ChatGPT does better. If you give these models actual quotes in layman terms of people just describing their illness, doctors do way better than ChatGPT. So these models are useful and they learn something, but the things that they learn are still, it's like everybody who's actually tried to cajole a response that they want just by tweaking a prompt, understand that the way these models align your language onto a prediction task is not the way humans think about language. And I don't know if O1 through O3 solve that. I think they have managed to add some guardrails because of this chain process to make it in some ways certainly better. It is also dramatically more expensive. I think one of the problems I have with these models is just how expensive and it's not even just the environmental damage, say. It's just from a pure business perspective. It's a situation where every small request costs you like a cent or 10 cents or however. I don't want to price it. We haven't found at scale yet how to offset those costs. And I think that puts a very hard constraint on how much farther we can grow. This idea that let's build a bigger model and a bigger model and a bigger model. First of all, we're hitting the limits of not model size. We can push the model size bigger. What we're running out of is training data. And that's a huge problem for us. And on the other hand, again, I don't know, some of these benchmarks, honestly, my cynical take on this, again, I don't know, I should have asked you before who's the audience for this. Don't want to get you in trouble. I get the sense that a lot of these benchmarks are PR material. They're like marketing material. They are meant to excite investors. I don't know a lot of AI researchers who take them super seriously. There's certain language benchmarks that we care about, and a lot of them, I think, are like routinely being beaten by these models. Look, I can tell you that natural language processing as a field before and after 2020 is almost not the same field. I do take issue with these people who assume that like, there was nothing and then there was a big bang in like June 2020, which is I think when GPT-3 was released. That was June of 2020, if I remember correctly. By the way, alarmingly, that was like 4.5 years ago. I don't know if you can, can process how much time passes. But it's not the case. Like the technology that drives these models has existed, since its inception is around 2014, 2015. The first seminal transformer paper is Attention is All You Need, which it's a Google paper from 2017. I've been working with models like BERT. It's a predecessor you can think of. I don't want to get too much into the technical details, but it's a predecessor to the GPTs of the world. It's like it has a different perspective, it uses different tricks, but it's of the same family. It's much smaller. It's like 110 million parameters. I think it's vanilla size. It's 100 million, around 100 million parameters, which was still huge in 2017, 2018 in 18 terms. It was because before that I've never seen a model with more than 20 or 30 million parameters. Now we're working with like the smallest language model you will find of the contemporary bunch is of the 3 to 7 billion parameters. That in that sense, the envelope is being pushed aggressively. I think I don't, how should I put this? I think we're making tons of progress. I think these new models are credited, and also a bunch of other companies release new models around the same time, and they're all impressive in their own right. There's certainly a lot of things happening. I still feel like we're missing a bunch of building blocks, but we can talk about it later. I've been monologuing for like the last few minutes.
Wow, this is remarkable, and it's still amazing how early we are, and really, like you mentioned, how efficient is our brain. I also read research that says that in some cases, people actually can function with half their brain removed in some physiological cases.
Especially young children. The neuroplasticity of a brain, especially of a child, is so remarkable that in some cases, not all cases, children can have massive, big parts of their brain damaged and can still function. Again, we don't understand when and how, because there's also cases where that happens and then someone never recovers. So that's part of what we don't fully understand. I am of the camp. There's been a bunch of camps. Again, I don't want to take a read. I'm going to ask a question, but I'm one of the people who think can take inspiration from the cognitive sciences in terms of pushing the envelope, in terms of like reasoning about types of reasoning. I don't know if you want to, because some people are like, we should figure out what the brain does and then emulate this in hardware, and that's going to be our AI. I think that's a dangerous path because we're still very far away. First of all, we're very far away from understanding the brain. And I don't think we want to wait up on that to build AI. These models that we do, even if you can complain, we can complain. I complain all the time about the limitations of what these models do and don't do. But I don't think it's arguable that they are insanely useful. My son has been struggling. One of my kids has been struggling with some types of math problems. With in an LLM, I can build an entire app for him to practice, and it took me, I want to say 30 minutes, something that I would have needed to have spent probably 2-3 days to do the same amount of work. It does mean the one thing I will caution is that people say, "Oh, then I can write software." It's like you can have the LLM write it for you. If you don't understand why it does, and if you don't know how to do it yourself, be very, very careful, because these LLMs, like I had to fix like a variety of things that these models do. This is part of I think one of the issues that we have right now is that because these models, I'll give you one of the, I don't know how much technical I want to get into it. It's obvious to those who are actual practitioners that these models don't fully understand. Again, we humanize them, we anthropomorphize them. It's like, we use language like the model doesn't understand. I don't know what the model wants. The model doesn't want anything, and it doesn't. I'm a radical. I'm like, there's a spectrum of people who think that like these models are like proto-sentient, basically, that they have like their own initial cognition. And there's people who believe that these are basically glorified toasters or like these giant matrix manipulation machines. I'm not all the way to that side, but I'm closer to that side. These are ultimately what you see is the outcome of matrix multiplication. And then you can come and say to me, well, maybe all the brain does is matrix multiplication, which it may very well be. We don't know. But yeah, you're right. We're very early. And I take it as both a blessing and a curse because I feel like there is an impatience, especially among what I would define as the investor class, towards they want earth-shattering big results and they want them now. And they're spending the amounts of money that would imply that they expect them now. And I worry. I think that what we're doing is of value, and I think we're making tons of progress. But are we gonna? It's partly the question of like, what's the horizon? If people will expect AGI in 5 years, do I think it's possible? It's possible. Do I think it's like? I don't think it's likely. At least based on, again, having said that, you don't know what's going to happen. You asked people 10 years ago if they think that what LLMs can do routinely now would be solvable in that time frame. I would say a huge portion would say probably not. So I have the humility to say that it's possible. We don't know. I do feel like part of what worries me is that we're pushing things faster than we can understand them ourselves. Is my biggest concern with these. We're pushing scope, we're pushing scale, and we're not stopping to actually understand what's happening in these models underneath the hood. Part of it is because it's very complicated. I don't know, like a lot of the times these models do things, and I don't think we fully understand why they're doing what they're doing from like a technical standpoint, not just from like a hand wavy or from, again, there's this mystical perspective of basically saying like, well, the model is proto. The argument I have with the kind of, again, I don't want to name names, the individuals who say things like the model's basically borderline sentient, is that it opens the door to a lot of mystical thinking about these models. So it's like if the model has intent and a personality, then who among us can tell you why the model does what it does? I think that is an ascientific way of thinking about these. Everything that the model does, there's a mechanism making it do it. And by the way, I think it's true for people as well. And I think we need to understand those. Yeah.
Wow, couldn't agree more. So I think you led us very nicely to the next question, which I think you touched on partially. There's a lot of money being poured into the AI industry. Good money after good money. OpenAI raised 22 billion. Entropy with Claude raised 14 billion. XAI raised 11 billion according to a 50 billion evaluation, and built 100,000 GPU data center. And Sequoia Capital calls it the 600 billion question. So you touched on the next 5 years and your thoughts about will we reach AGI? I want to ask you, what do you think we are still missing? I know it's like a complicated question, but is it scale? Is it more data? Is it a different architecture? If you can touch on that.
I also was saying that it can't possibly be just data, because if it were, first of all, if it were data, then we're screwed, because we have managed to milk I think most, if not all, possible digitized data, and a lot of the stuff that hasn't been digitized yet is being digitized. I also, again, like I said, you look at how children. There used to be a conference, the International Conference on Developmental Learning, ICDL. I think it's fallen off out of favor in the past 10-ish years, but it used to be a place for, say, cognitive scientists and AI researchers to kind of meet and discuss this idea of like developmental learning, or like how acquiring knowledge happens over time, how to learn how to make decisions over time. And a lot of it was inspired by watching, say, children, and like babies and children learn, watching animals learn. And again, I'm using inspired by because I don't think AI's role is necessary to emulate the way. I mean, some again, there's the purest streak who was like, let's figure out how neurons do what they do, and then just put it up at scale. Let's build a mechanical brain. I think what again strikes me is just how much and by the way, there's still disciplines in machine learning where we're very good at making systems generalize pretty efficiently in for specific tasks from not a lot of data. And it's true in robotics and reinforcement learning, where it's just you can't just do. There's a strong bias in the AI frenzy right now towards language models, because those are the only ones where we can kind of weaponize data acquisition the way we have. It's a mix of things. Part of it is a new family of learning techniques. Like it used to be 10-ish years ago, you would have companies like Google and then Facebook, now Meta, hire armies of linguists, and they would basically annotate sentences so that the models would learn grammar and structure out of basically what we call through supervised learning. Examples that have been annotated by a person who we consider an expert so they can generalize from that information. And then along the ways, we're like, well, let's try to learn from the input to itself. Let's try giving us, give me a paragraph and I'll give me a sentence. And I'll try to predict the rest of the paragraph from the first sentence. Or I will try to take a middle sentence in the middle and complete the paragraph on both ends, which is kind of like the logic of like what BERT kind of thinks. I don't want, again, I'm oversimplifying. But that opened the door for a whole family of training regimes where you can actually train on billions and trillions of documents, because the bottleneck was never just compute. The bottleneck was that you could never have enough linguists annotating pictures to tell me a cat's there and a jar's there and a dog's there and a car's there, which is how we did machine learning up until like how we did machine learning for vision 10 years ago. I think we have some of the insights that we have are inspired, like transformers, which is the underlying neural architecture that is most common, basically formalizes this notion of attention, teaching the network as part of the model to know which parts of the input and context and history are relevant for the next output and it was inspired by studies of human visual attention and human like auditory and like textual attention, but ultimately ended up being its own thing. I think unless you're like a truly a zealot, I don't think a lot of cognitive scientists think that how the brain manages attention and recollection and memory is similar to how we do it in our current, architectures. But it's a very useful idea. I think we're missing at least some similar ideas. One thing that I would argue that we've kind of in the sweeping, this tidal wave of contemporary AI models that we have, we've kind of put on the side is this notion of of logical inference, understanding the semantics, having like kind of like entity disambiguation. There's these things that we used to study that were part of the AI and machine learning manifold of things that we cared about and we studied. Like this idea, because my always contention is that like I still oftentimes get the sense that these LLMs are very good at imitating understanding without actually understanding. Then you see countless examples, and not even going to the Emily Bender argument of two octopi, sort of like an octopi eavesdropping on two people, and it learns how to imitate the communication. But an octopus can never know what a human talks about when he talks about his house being on fire, because an octopus has never seen a house and it's never seen a fire. So I'm not even going insofar as that. There's still this notion of the model understands things kind of nebulously in a way that kind of emerges, but only insofar as it's helpful to completing text, which is partly why when you ask it to generate, is you ask Midjourney to generate physical objects, it can often generate things that are like blatantly aphysical or like not consistent with our understanding of like a model that produces, say you ask it Midjourney or other visual model. I'm using visual models here because it's easy to illustrate this and people see this all the time. People celebrating in a party. What you're going to see is in the focal point of the image, you're going to see clear people. Go outside the frame, it's just going to be a mess of heads and arms and shoulders not coalescing into, because the knows this kind of general structure. Oh, there's going to be a blob of people here with heads and shoulders. It doesn't have the semantic abstraction of like these are individual people that needs to be delineated. And I'm not sure that emerges on its own. The same way that they had to do a lot of, and the way we go about this is these bespoke hacks. Like hands have been notoriously a huge problem for image generation. And it makes sense because you never see two hands that are exactly the same in images. They're always in flux, they're always obscured by something. It's hard to count. These models don't know how to count, by the way, because again, it's not something that just naturally emerges. And you will see this like, there's a lot of things that need to be, this is why we teach kids things, because a lot of things need to be instructed in order to be learned, and they're not going to be emergent on its own. I don't think some things might be emergent for some people, like basic intuition about quantities. But if you just take a baby and put him in a cage for 18 years and you take them out, no matter what their experience, I'm not sure they'll know how to count. They would know that they would naturally know what, or to organize numbers from 0 to 10 and then understand how addition and subtraction work. So all of this is to say that there's too much onus being put on this assumption that mimicking understanding on a large enough scale leads to actual understanding. I've not seen a ton of evidence. I have seen evidence that if you give it enough training data, you're always going to find, the model is going to find something that rhymes well enough to fool someone for long enough. Like, do I think, like, this is partly why I think the Turing test is probably no longer useful. Do I think an LLM can fool many people for 5 minutes? I 100% think it can. But to think that that means that we've achieved AGI just means that people haven't read Alan Turing's original paper from 1950 or didn't understand it. Something interesting from that paper is that he doesn't say that that's intelligence. What he says is the question of whether a system can be intelligent is too abstract and vague to be useful. It's not a useful scientific question because we don't know how to define it. He says that let's define it a task we can build towards and then build toward it. So in that sense, the Turing test achieved what it was aimed for, which is pushing AI research forward. We need to come up with better tests. When people ask me, do I think we're going to have AGI in 5 years? My gut sense is like, that's the wrong question to be asking. The right question to be asking is what kinds of capabilities we're still lagging on. And I would argue that, well, there's the thing that we're missing the most right now is consistency. Consistency in terms of getting the outputs that we want, consistency in terms of trusting the output that we get. Again, if I ask GPT to produce code for me, I trust myself enough to know how to use it responsibly and understand it if it does what it does, if it understands. And I've seen wild things. Like you ask GPT to add comments. So sometimes it would, oftentimes it would do fine, especially the more boilerplate this stuff is. But sometimes it would leave comments that are clearly wrong, like that are just not what that piece of code does. Because again, it's a language model and it's doing this kind of weird remix of like 50,000 other examples that are sort of related. So it doesn't have, because it doesn't understand the semantics of what it does, there is no real sense of enforcement where like, I understand what the code does and I understand what the description does and the code and the description align. But if you let someone who's not a proficient engineer, is not a proficient scientist to run wild with these, you will get something that's either dangerously faulty or also possibly malicious. And I think there's growing concerns about potential maliciousness. This whole thing of like data poisoning. I don't know, have you heard the term data poisoning? So that's a huge concern. The more we get this into this loop of garbage in, garbage out, the more that people are trying to actively inject data sets with stuff that biases it in ways that are either motivated or downright damaging. And just the people just trying to hack these models because these models are not well understood. It's oftentimes surprising for people to figure out ways to hack them. And then instead of finding a deep solution, it's just arms race of patches where we just close that one loophole that someone found, and then somebody else finds a different loophole 2 weeks later. So yeah, there's still tons of work to be done.
Amazing, and very, very insightful. So I want us to switch things up and
Sure.
talk about human consciousness. Two of my favorite books about the topics are Consciousness and the Brain, Deciphering How the Brain Codes Out Our Thoughts by Stanislas Duhan, which explores the neuroscience research of consciousness, and I Am a Strange Loop by Douglas Hofstadter, which looks at consciousness from a more philosophical standpoint. Yeah. Can you tell us, Elad, is there, like, what are the best open source or not open source attempts today to replicate directly human consciousness?
First of all, that's a good question. I mean, the way science works, I mean, it depends. Okay, if you're doing science from like a large company where you have to convince them that you're going to solve a problem. It doesn't matter if you're like you are working for a large company or you are a small company that's trying to get money from investors. You need to convince them that you're trying to solve a problem that saves them money. And that's, or like, will make them money. And on the other side, if you're an academic and you're trying to solve something, a grant proposal that says, I'm going to figure out how to build consciousness is probably not going to get funded relative to something that says, like, I want to understand how memory works in these and these contexts. So, because if it's too large, and so, I mean, you sometimes have these like big challenge 5-year grant projects. They're usually pooled together between like 20 universities, and you have to convince them that you have because like if you and I came to the National Science Foundation and we're like, we're going to figure out how to build consciousness, then they will laugh us off the stairs. They will not entertain our request, probably, unless we have really good arguments why we figured something out that someone else didn't. All of this is to say that I don't know, everybody says oftentimes give this as like a high motivation, not in industry so much, but in academia for sure. No one's actually actively doing that. People are picking much smaller fights within that big manifold as building blocks. One of the troubles that we have, are you familiar with like kind of like the kind of the Chinese argument, the Chinese room philosophical question is like, nope. let's say I put you and so it's kind of like let's say I put you in a room. And this is what's called like I'm trying to remember the name of the philosopher who came up with this. John Searle. I think it's John Searle. So he says this, and this was like 1980, so this is entirely prophetic, but he says something like this. Let's put you in a room, and I bring you a bunch of books, and you get sentences in English, and then you open these books. These books are all in Mandarin Chinese. And there's a whole pages up. This is this is like old school. So there's a bunch of books, and these books are basically a series of nested instructions. And from those instructions, from an English sentence, you piece together symbols in a Mandarin script, and you put them out. And you keep doing this. The person outside thinks you're speaking fluent Mandarin, but you have no idea what you're doing. You're just piecing together from instructions. There's been he's not saying that. He's asking the question of like, is the room sentient? Is there intelligence involved in speaking Mandarin in this process? Or you can basically say like it's coming, I'm sorry, I may have misrepresented. Like imagine the full version, which is like you get sentences in Mandarin, there's instructions to translate this to other symbols. You're just following instructions. At no point does it cross a language that you understand. You're just doing the processes. Are you speaking Mandarin? Now, the intuitive sense of us is like you don't know what you're doing, so you're just creating sequences, and to an onlooker, you're basically cheating them into thinking that you're speaking Mandarin. Now, there's a philosophical argument to be made that you yourself might not be sentient in Mandarin, like you're consciously speaking Mandarin, but the machine that is you plus the instructions plus the room plus the books is as an entity speaking Mandarin. But then it becomes a question like, where is the consciousness in there? Where is the self-reflection? This experiment basically shows the limitations or the challenges, the mechanistic perspective, which still dominates machine learning research and AI research about understanding consciousness. I think consciousness is too ill-defined philosophically still. Again, I'm not a practicing philosopher. I'm a computer scientist, so I don't want to overstep my purview in that sense. But I do feel like when you tell me I want to build a consciousness, I mean, as a scientist, I would go like, first we need to understand what consciousness is. I think, and this is one of the things that worry me about all these talk of chains of thought and self-reflection, is that we are at the point where the model can produce a sequence that looks like a chain of thought, but I am not convinced that it's actually thinking. I think you can treat chain of thought as a form of output, like any output. So it's theater. You told him to produce a sentence, it produces a sentence. You told it, I want you to produce a sentence, but do a bunch of overcomplicated steps en route to that sentence. It will do it for you. And no, it's seen enough examples in data of how chains of thought should look like to imitate one that's sort of passable. Does that mean that it understands? I think, again, I'll put that aside and I'm going to wear it. People ask me about this because I worked a lot in, say, music generation and generative AI for music. And it's like, and by the way, I'm a huge fan. I mean, lawsuits notwithstanding, I think these are tools that, Suno and I forgot the other one. I forgot the name of the other one. These types of tools that can generate, you basically tell me, I want a 90s indie pop song about how my washing machine broke. And it will produce you something and it's going to be amazing. I think it's super fun. Again, the jury's out on whether any of this is useful. And I remember I was sitting in a panel in 2016 at a conference, and they were talking about we'll be using this for making soundtracks for movies and for video games. And I was like, you're cutting out the cheapest part, the weakest part of the chain, which is like independent artists, independent composers, independent graphic artists. These are not the cost drivers in the process of making a film. So I'm still not sure I'm seeing the business case, but in terms of fun, it's endless amounts of fun. All of that, but let's say I don't think those models by themselves are making art, because a lot of it is about communication and intent, and you want to say something, you want to tell something. And I don't think these models have something. I don't think they have as themselves yet that they want to that they could share with us. I still see them as these glorified mathematical manipulations machines that are incredibly powerful. Can we use them to make art? I think so. I'm not a Luddite. I think these tools have tons of interesting uses, and I think they can be used to expand our limitation. And just, I think there might be a day when they do become sentient. Yes, but part of it would involve then building true autonomy, which revolves around independent experience and independent goals. And I think I'm coming from also reinforcement learning. Part of it is this question of intrinsic motivation. To answer the question of is ChatGPT sentient, you have to ask yourself a different question to my mind, which is what does ChatGPT want? And I don't know if ChatGPT wants anything. I do hope that when it comes up that it does want something, it's going to be like benevolent AI and not Skynet, say, or Ultron. I don't know. We'll find out. I don't know if that answered any of your questions. But
wow, this is fascinating. Like you're touching on things that are like self-will, and for my next question, I want to simply define human conscious as what humans can report as going on in their head, and I want us to look at the design that we can report as humans, and to ask you, first of all, do you think that consciousness is something that can spontaneously arise from large models, or will it need to be specifically crafted? Like, I know there's this field called the MacInterp, where people actually that you touched on, people try to figure out what's going on inside of the AI models. And I know that they found out that things like circuits like curve detectors and high-low frequency detectors, and
we've known Gabor filters, and we've known this for decades. Like, one of the first things we found out about vision models is that the lower layers closer to the input, they kind of self-evolve is something that's similar to Gabor filters, which is also similar to how human vision works. Just because it's useful to detect structure. Like you said, a frequency detection, what's called edge detection in images. So a lot of it is because we understand the visual cortex relatively well, so it's easy to latch on to this. We understand it better than we understand. Again, I'm not a cognitive scientist, even though I'm adjacent. The trouble with what you're asking, again, I'm sorry to hijack this, but I need to drop in like 5 minutes, so I want to try to be efficient. The trouble with that frame of thinking is that we tend to oversell our consciousness. Like, I think what we tend to do is we assume that our consciousness is in the driver's seat, where in a lot of cases it's in the passenger seat just narrating. Like we know this from tons of studies. Like there's been a study where you put an electrode in someone's cortex that every time you zap it, that someone just has an involuntary hand movement where they have to move something. But you don't tell the patient that. You don't tell the participant. So you don't tell them, you tell them something different. So they have no idea. They're not primed to know that that's what's happening. Then you ask them, why did you move your hand? And like 80% of the times, they will come up with an excuse. They come up with a reason. Oh, I had an itch. I needed to move my elbow. Something felt weird. I thought there was something there. And this is because we abhor. So this is the real job of the brain, of the conscious part of the brain, is to narrate, to explain to us what's going on. And this is that we know about. This is why fake news exists. This is why we have conspiracy theories. Is because we can't accept it. We just don't know. So we our brain just goes to making stuff up. It's like, and this has been known. There's been in a study where they show you a picture. It's a fabricated picture of you, I don't know, eating ice cream with someone in a carnival. And like a shocking percentage of time, people will just make up a story with complete self-conviction on how that happened and what was the backstory, where it's never happened. It's faked. And again, so what I'm trying to say, but I think there's something incredibly telling so consciousness is developed because it's evolutionarily useful to have consciousness. Otherwise, it wouldn't exist. To argue that it's been too successful, like the jury's still out on what's going to happen with mankind in 10,000 years or 100,000 years. Like evolutionarily speaking, we might be a dead end. We don't know yet. But for the moment, we know consciousness evolved because being really, really, really smart primates has paid off because we're not the fastest and we're definitely not the strongest. But we have really good eyesight relative to other animals. We are upright, which does confer some advantages. Being upright enabled our brain to grow huge. And huge brains are themselves a killer advantage. They're a game changer. Walk around. You see, what do you see around you? You see people. You're not seeing cheetahs. So we've obviously played our hand pretty well from a species that was near extinction around this mini ice age 100,000 years ago. There was a bunch of volcanic eruptions and there was a small ice age. I think it's been reported, I don't know how factual that is. Again, this is outside my field of expertise, that they estimated like Homo sapiens populations drop to several thousands planet-wide. And we're all offshoots of those. They're pretty hardcore survivalists. So we're all offshoots of them. So we're a pretty intense species, is what I'm saying. But I don't know if intelligence is going to spontaneously evolve. Again, it depends on what you mean by spontaneous evolution. It might if you give the evolutionary process enough degrees of freedom. And there's been a field of study that I'm familiar with that I touched on. It's called neuroevolution, which is this idea of architecture, like neural models that don't just learn, but also change their structure as they learn. It's kind of been, I want to say, marginalized with the sweep of these giant complex architectures. So because these were like toy-like models, this was stuff that was happening pre-deep learning, pre modern architectures were happening like in the 90s and 2000s and 10s even. But I think some of it, if you were serious about evolving intelligence, you need to probably allow architectures to change. The trouble is, we don't have the breadth of, evolution works over millions and billions of years, and it actually happens in the wild, in the world. I think a lot of it, part of it is, and I'm a big believer in grounding. I think part of what the thing that limits AI now is that it only sees text and it doesn't know what a cat is and what a dog is and so it kind of learns contextually. So it kind of, again, it does the theater of it. And I'm sure that some representations do emerge, but it's not grounded in a coherent structural understanding of the world that allows us to understand that shoulders can't be fused together and cats can't be riding motorcycles. I don't know. I'm just giving dumb examples for things that, like, the model doesn't preclude, because you can't preclude all possible combinations, but we have common sense reasoning and understanding of the semantics of the world that allow us to limit the range of possibilities in ways that are constructive to decision making. I think ultimately a big part of it is, like, what do we want? Like, is intelligence necessary for ChatGPT? It depends on the tasks. I'm not convinced that, I mean, again, am I interested in it from like a high level abstract? I think it's an incredibly noble and meaningful scientific pursuit. I think it's the same as like putting a man on the moon. Are there like possible, are there externalities, useful externalities? Is there like strategic utility to putting a person on the moon? Not clear, but it pushed science 50 years forward, the space race. And I think the AI race, quote unquote, is pushing mankind forward. So in that sense, I think it's useful. But I don't know if we can trust um like private equity to be the long-standing funders of said effort. And again, this becomes a question of like philosophy and economy. Yeah, you obviously want to say something, and I keep hijacking the conversation. I'm sorry.
No, this is like awesome, and I kind of like hear your sentiment of like putting the AI on the same chessboard as humans as being like essential for the computer to actually be able to win humans in chess. And I know you are also in a time bind, so I don't want to take too much of your time. And what a beautiful way to end our talk with the message you just gave us. So Elad Liebman, always a pleasure. You mix up
Absolutely.
things from different fields, and I really hope we can do this again and
Absolutely.
extend the talk, because I still feel like I have a lot to learn and a lot of questions. So again, thank you so much for taking the time here.
A pleasure. Nice talking to you. Take care. Have a good day.
Thank you. You too. Bye bye.